Hello students, today we will start another topic, that is electron displacement effect. So under the electron displacement effect, here four effects are there. The first one is inductive effect, then second resonance effect, third hyperconjugation effect, then the last one, fourth, that is electromagnetic effect. So let's start inductive effect. Inductive effect, that is the permanent polarizations of a covalent bond towards more electronegative atom, developing a partial but opposite charge due to differ. Here this is the introductions for the inductive effect. So now let's see in detail for the inductive effect. Now here this covalent bond is formed by sharing of electrons. Now here this hydrogen and hydrogens, that means one hydrogen having one electron, another hydrogen having one electrons, so they are sharing to each other. When they are sharing to each other, they make single bond, they make single bonds, and then that single bond, it will represent as a dias only. So that is the basic conditions for sharing the electron only. Now here the another number 2 point, if similar atom involved, electron pairs remains in the middle. Now here this hydrogen and hydrogen, so hydrogen and hydrogens, one hydrogen atom and another one hydrogen atoms, that means similar atom only. So these similar atoms here sharing to each other and there is no having any gap, so that means both are equal force, and then in the middle it will have for what, this dias only. So that means they are sharing to each other, and then the number 3 points, that is if these similar atoms involves electron pair shifted towards more electronegativity atom. Now here this hydrogen and chloride, so hydrogen and chloride, they are different atom only, they are different, that means these similar atoms, and then these similar atoms, they have to shift one electron, they have to shift that to the chlorine, and another one shifted, that means what, they also having for what, sharing only. So when they are sharing, that means one, this chloride will have what, del negative, and then hydrogen will have del positives. So that means this chloride have more electronegativity than the hydrogen. Now these 3 points are the introductions of the inductive effect. Now here the next one is the definitions for the inductive effect. Here shifting of electrons in covalent bond from low electronegativity atoms to high electronegativity atom. So now here this hydrogen having for one low negative atom only, and then this one is high electronegative atom. So that means this electron have to shifted to this, so that means they are making shifted for the covalent bond only from low electronegativity to high electronegativity. Then always sigma electrons are displaced only occurs in single bond. So now here carbon and carbon, so carbon and carbon having forward sigma bond is there, so this one is the same atom only, similar atom only, and then here different atom. So now here hydrogen and the chlorides, in there also having sigma electrons, then fluorine and then chloride, so this also having sigma, so that means it occurs in single bonds only. Now here then another number 3 points, that is it is a permanent effect only. So whatever the sharing of electrons, these are the permanent effect, and then it is distance dependent decrease when the distance is increased. Now here carbon, so that means what, 3 carbons are there, then these 3 carbons are attached to this fluorine. So now these fluorines have will have for what, more electronegativity only, and then this will have for what, the distance will depends, that means when it is decreased, that means what, it will have more electron, this carbon will have for what, less. So compared to this one, it will have more only, and then this carbon has, it will represent for del positive, and then this one will have what, 2 del positive. So now this one compared to this one is less only, and then this one is less only. So the more one is this carbon, it will have only positive, so it have for what, more atom. Now another 5 points, that is it is two types, which depends on the types of the group attached. So that means this inductive effect, it have two types are there. It also depends on the group, either functional group or other types group, either electron donating group or electron releasing group. Now here let's see this carbon, here also one carbon, here also one carbons. So that means how many carbons are there? 3 carbons are there, and then this 3 carbons that will attach to X only. So now X, that means what, halide group only. So that means this one will attach to halide group. So now these 3 that will represent as a system, and then this halide X, it will represent as a group only. So now this X, it will have more electronegativity, more electronegative only. So now here this carbons having what, covalent bond. So now here, like before in the previous one, I already explained this halide, it will have more electronegative than the system. That means this one will have more only, so it will represent as a del negative. Now another one for this 3, we will just compare for this 3. Now here this one will have more atom only, more atom, that means more electronegative atom only compared to this. So this one is least, and then this one is less only. So now these 3 are the system, and then this one will have for what, group only. So that means this is minus I effect, that means negative I effect, minus I effect, that is electron withdrawing from system to group. So from system to this, so that means whatever the electron, that will have to withdraw to the group only. Now X is called minus I effect group. Now here this another one, here 1 2 3, this also the same as this. So now here this is less electronegative than the system, so this one is less. So now if it is less, then this Y, it will represent as a positive, and then carbon, it will have more only, so that will represent it as a del negative only. So like that, this one is will have more, this one less, this one less only, so that system. And then this E, that electrons, it will be donated from the group to the system. So before one is system to group, here group to system. So group to system, that is plus I effect. So now here Y is called plus I effect group, and then here X is minus I effect, Y is plus effect. So minus I is electron withdrawing group, plus I effect, that is electron withdrawing group. Now here this is an aromatic one. So this aromatic, that means this one is benzene. In benzene, it will attach halide group. So now this X, that is a group, and then this benzene, that is a system. So now we have to shifted this electron from benzene to X. So that means benzene to X, that is the minus I effecting group only. And then now here another one, so this one is a minus I effect, and then here this one is plus effect I effect group only. So now here Y, and then Y to system only, that means group to system. So electron system from Y Y to benzene, so that is positive effect, I plus I effect. So now here another one, here some negative minus I effect, and then minus positive effect. So now positive negative one, we just see all the functional group, that is aldehyde, then alcohol, OH group, then ketone, then amine, cyanide, and then carboxylic. So these are the minus I effect. And then here all alkyl group, that is CH3, then C2H5 ethyl, then CH, then CH3 twice time, and then CH3 three times. So that these are the alkyl group, and then it is included under the positive I effect. Now here some applications of the inductive effect. So now let's see 5 points are there. These 5 points, it needs to be have the inductive effect when the this one stability of carbocations, in that time inductive effect will have. And then the same as the next one, carbene also, then stability of free radical, then acidity of carboxylic acid, basicity of amine. So these 5 points are the 5 points are the applications of inductive effect. Now next is resonance or mesomeric effect. So resonance, it will be represented as a R, and then mesomeric, it will be represented as M. So now here chemical structures can be written in two or more than two different form. Now this chemical structure, this is a chemical structure only, so these chemical structures, it will form two in different form. Now here this is a benzene, we already know that structure is a benzene. So now here in the alternate positions, it will have double bond will be there. So now here this it will, here it have our pi bond is there, another pi bond also there, another pi bond also there. So that means three pi bonds are there. So now this three pi bond, one bond we have to break and then given in this carbon. So when it is given in this carbon, then it will be it will come as a negative sign. So the last ones, the when these bonds, it will be rotate, and then after that it will be shifted these structures only. So that means two or more than structure in different form only. So here, and then another one, see this, so this 1 and 2, that will have, it will represent as a it will be called as a resonance structures or canonical structure. So now in short we will show as like this one is a resonance hybrid. That means this structure is shifted of pi electrons. Now number 2, these different structures are called resonance structures or canonical form. So I tell you here, this one is the first one, and then this one is the second one. So first one and second one, that will be the different only. So that one we just say that the different structures, we call it resonance structures or canonical structure. Number 3, that means here what I told you, that this pi electron, they have to shifted electrons in this carbon only. So in this carbon, so now resonance structures are made by the shifting of pi electron. Then number 4, all the resonance or canonical structures are imaginary structure. So that means here, if we are rotate like this, then that means that is also an imaginary structures. Now none of them can explain all the properties of molecules. Now here, this here to here means, that means this one, it have our carbon here, one carbon, and then another one carbon is there. So that means the bond length is 154 picometer. So that means it will represent as a single bond only. Here one carbon and then another one carbon, so the bond length is 154 picometer. And then here we just see here double bond is there, so carbon and then one carbon is there, so in between that double bond is there, so the bond length, it will be different. So that means 134 picometer will be there. Now all the resonance or economical structures can be mixed to form a hybrid structure. So whatever the structures that will form as a resonance hybrid, so that will represent as a round, so it will be formed as a dotted, so that will call it resonance hybrid. Now number 7, so resonance hybrid structures is called a resonance hybrid. So that means hybrid structures, whatever the structures, now here this is dotted one, so this one is a hybrid structure, so this is a real structure. So now another one, all the properties of molecules can be explained from the resonance hybrid, that is the real structure. So from this structure we can explain all the properties of the molecules. Now all carbon bond length equal to 139 picometer experimentally proved that carbon and carbon single bond carbon. So carbon single bond carbon double bond carbon in the benzene ring can rotate the bond, the delocalizations of the pi electron. So that means it will be dotted, this dotted point denotes that the delocalizations of the pi electrons. So now here these dots are present there, so that will be denoted as a delocalizations of the pi electron. So pi electron is not in one position, so these pi electrons, it will not have one in the one position. That means each and every carbon's atoms available. These are the phenomena exist in resonance structure. Now here some example, we just see carbon dioxide, carbon, now carbon double bond, sorry, oxygen double bond carbon, then double bond. So now here double bond in between here. So now here from here it will be given, and then here it will have our triple bond will be there, and then this one will given, single bond will be there, then negative charge. So that means these are the delocalized of the pi electron. So delocalized of the pi electron is represented here. Now next RNO2. So RNO2 here, this one pi double bond, it will be given brag and then given to this oxygen. So when it is given to this oxygen, that means these oxygens will have more electron, so it will be represented as a negative. Now then this one from this one negative having, so this from here it will be given in this bond, then that will have our more electron. So now for this two, it will represent one, that is a delocalized of pi electrons, it will represent that is here. Now the last one is a RCOOH, then this it will be same as like before. To show the resonance molecules must have pi and then electrons. Here see this. Now here no pi bond, so that means here all are single bonds only. So all are single bonds, that means it will not done the resonance structure. Here also it will have two, but this also we cannot do, and then here only one cannot, this one also cannot. Now to show the resonance, and the compounds must have the conjugation system, that is pi, the CH2 double bond CH and then CH, then double bond CH. Now here from here double bond is there, one bond we have to break and then given to here. So when it is given to here, that in that time it will have double bond, and then here it is given to here. So here it will have more electrons, that means it will represented as a negative. So this one it will have less electronegativity, electron. Now next one is also the same as here, CH2 double bond CH, then negative, then single bond, and then here CH2 and then CH double bond, then CH2. So that means here break and then given to here, then double bond, then here it will have less, that means it will be represented as a plus. So same as the rays of this example is also same as before. Now the last one, CH2. See, we just see CH2, then CH, and then here CH2. So that means one electron will be the free radical is there. So that free radicals we will just see here given to here, then when it is given to here, that free radicals will be lost. Then another one we'll just see here, CH2 double bond, and then here single bond NH, then lone pair is there. So this lone pair will be given to here, then double bond will be there, then it will be represented as a positive, and then here given to here, that means it will have negative positive single bond, and then it will carry negative charge will be there. So these are the examples of resonance which have conjugation system. Now here types of resonance, two types, like before inductive effect, plus R effect, then minus R effect. So now here this is the aniline structure. So this aniline structure, here lone pair is there, and then this will be given to here in this bond, that means carbon and nitrogen in here. So when it is here then another one, it will be brag and then given to here. So now we just see this is one, this NH2, this amide group, that is a group only, and then this benzene, that is a structure, that is the system only. So that means group 2 system, group 2 system, that is positive R. Then now we just see another one example. Here CH2 double bond CH and then single bond Cl. So lone pairs are there, 1 2 3, and then here it's given to here, and then another one shifted to here. So this one is also the same as group 2 system. Now group 2 system we already know in the previous also. So that means what, shifted to group, from group 2 system only. That means migrations of electrons from group 2 system. Now here group which donate electrons to the double bond or conjugate system or aromatic system, that is plus R effect. Now here we just see this one is a double bond, so this one we shifted to here. When it is shifted to here, that means what, this one will carry negative charge, and then this, and then here only single bond will be there, and then here 1 2 3 4 5 6, so 6 electrons are there. So 1 electrons it will given to here, this pairs of given to here. When it is given to here, that means double bond will be there, and then it will carry what, positive charge here. Chlorine will carry positive charge. So these are the plus effect, plus R effect. So now next is R minus R effect. So minus R effect, this one is a group, and then this one benzene structure system. So now given to here, this negative charge will carry in oxygen, and then here positive charge will come. So that means what, system to group. So before one is group to system, here migrations of electron is system to what, system to group. So now here the same as given to here. So now group which withdraw electron from double bond or conjugate systems or aromatic system. So before one is donate, but in minus R effect, minus R effect, that is withdraw electron. Now here these some groups are there. See, functional groups are there, OH, then NH2, OR, CH3, then CH2, CH3, then phenol, then ethene. So these are the positive what do you say, resonance effect. So plus R effect, and it includes in it also includes for what, halogen also. That means fluorine, chlorine, bromine, iodine. So next this minus R effect also, this acid amide, aldehyde, then ketone, acetic carboxylic acid, then ester, then cyanide, then nitro. So the nitro group, so this is also minus R electron withdrawing group. So here are some example for the R electron withdrawing group, plus R electron withdrawing group. This is the aniline structure. We just see the resonating structures of positive resonance effect. Now here double bond electron pair given to here, when it given to here double bond, and then it will have what, positive charge, because less electrons will be there, and then this one given to here, then negative charge will be there in this carbon, and then this one again given to here in this position. Then when it is given to here, then double bond will be there. Then when this one again given to in this carbon, then negative charge will be there. So like that, this negative charge again given in this position. So when it is given to this position, then double bond will come here. Then Another one here, double bond is there. This one also we have to break and given in this carbon. Then it will have a what? Negative charge with lone pair. So now with this one given to here, and then before this double bond we have to break and then given in this nitrogen. So when it is given in this nitrogen, then it will come as a like before lone pair will be there. Then these are the canonical structures of the plus R effect, and then this one is the resonance hybrid only. So NH2 group that is supplying electron in the benzene ring. So now negative R effect here is also the same as C given to here, the negative charge, the same structures like before we just see, but here positive charge it will have less. Now let's see nicely negative charge, and then this one will given here double bond, then this one will have positive charge, this one will be given here, then in this position positive charge will be there. So it have what difference compared to the positive resonance effect. Now here positive charge will be there, but in the previous one that plus R effect, it will have a what negative charge because it will have much more electron. Here it is less electron. Now here this acid, carboxylic acid, that is the withdrawing group, that means what withdraw the benzene. Now the next one is the third one is hyperconjugation effect. So in hyperconjugation effect, in short we just know that it have what no bond only. Now in resonance, if we just see in detail, in resonance effect CH3, that is an electron donating group. So in resonating effect we already know that CH3, that is the electron withdrawing group. Then CH3 group do not have any electron pair or free electron. So that means this CH3 group, they do not have any electron pair and then or electron pair or free electron. So now here one question is there, why CH3 is an electron donating group? Because it is hyperconjugation effect of the CH3 group. Now some points of the hyperconjugations we just see. Now alkyne group having at least one alpha hydrogen. So that means in hyperconjugations with at least it will have what one alpha hydrogen. So now when attached to the unsaturated carbon or carbocation or free radical. So now when it is attached to the unsaturated carbon or carbocations, we just see now here this is an example for this. Now unsaturated compound only, this one unsaturated compound. So in this unsaturated compound here, this is the here 3 hydrogens are here. So this 3 hydrogen is alpha hydrogen only. So according to this point, now here we just see this bond is given to here. When it is given to here, then here double bond will be there, but this in carbon and hydrogen it will not have bond. It will be represented as only positive charge will be there. That means less electron. So it represents as a no bond if a no bond only. Now number 3, release electrons by mechanism similar to the electromagnetic effect. So that means this hyperconjugation is similar to the electromagnetic effect. So electromagnetic effect we will do in the after this. Now this effect is called the hyperconjugation effect and also called the sigma pi conjugation. That means double bond also there, then single bond also will be there. So because of that we just call it sigma and pi conjugation. Now third point, also called no bond resonance. So I already explained that. See now one example here it is there. So this one here carbon and hydrogen in between that no bond is there. So we just say that this is before it is having bond, but when we do the electron transfer to the next one, after that it will not have bond. So it will represent as a positive charge. That means hydrogen will have less electron. So it means that this is called no bond resonance. And then another one, these methods we call it Becker and Norton effect. So Becker and Norton effect also we call it for this method. So the next one, orbital representation of hyperconjugation effect. Now we just see here alpha hydrogen is there, alpha carbon there. So if in this carbon it attaches 3 hydrogen is there, we just say 3 alpha hydrogen is attached. Now given here, then given to here, then negative charge will be there, then less. Then after that we just see this orbital system. So now here we just draw this structure, and then this electrons will give us to here. When it is given to here, this one will be sharing, so it will represent as a pi bond, and then it will have a what, double bond will be there. So now the same is here is also double bond will be there. So same as it's there. So now here it will have a what, in between that it will have a what, this hydrogen and this one, it will have double bond will be there, and then CH, and then hydrogen will be there, in between that single bond will be there, and then this carbon will have a what, more electrons there. So same as these structures only. So these structures it shows as a orbital representation only. Now the structures are hyperconjugated structure. So now here this is the example, CH3 CH2 and then double bond CH2. Now let's see this one. So now in this one alpha carbon is there, so 3 alpha carbon will be there, and then this one is saturated. So that means in hyperconjugations it needs alpha hydrogen in unsaturated chain. Now given to here, and then it will form here. So now we just see here one, and then another one we just see here. So that means this one will be given to here, then it will have one less, then another one will be there. So that means how many? 1 2 3. So 1 2 3, then 1 2 3, 1 2 3, and then this 4. So 4 hyperconjugations will be there. That means numbers of hyperconjugation structures is equal to numbers of alpha hydrogen. That means plus. So this alpha hydrogen, see now here 1 2 3. So this 1 2 3 that have to add with this alpha what we say, hydrogen. So it will come as a 4 hyperconjugation. So same as the next one is also the next one. So it will have for what, 2 alpha. So 2 alpha, that means here 1 2, and then this one is having 2 alpha will be there, so it includes as a 3 alpha. Now here also the same is here CH3 and then CH, then it will be given here this, and then after that after that this. So now here it will be given to here this, then here this. So now 1 2 3. So 1 2 3, that means it will have for what, 4. So same as here is also here free radicals will be there. So that free radical we just see here given to here double bond, then positive charge, then here double bond, then this one. So it will have what, 2. Now hyperconjugated structures versus to the stability. Now numbers of hyperconjugation structures is equal to numbers of alpha hydrogen. More numbers of alpha hyperconjugation structures, that is equals to the mass stability. Now here this is the structures. Now this structure here double bond is there. So in this double bond, and then that will attach 1 carbon is there. So in this carbon 3 hydrogens will 3 hydrogen is there. So 3 alpha will be there here, 2 alpha will be there here, also 2 alpha will be there. So that means here we just count 1 2, then 3 4, then here 3. So 4 plus 3, that is 7. So now the 1 alpha hydrogen will be there, so that will include as a 8. Now here the same as here also 1 then 2. Say here 2 hydrogen is there, so 1, then 2, 3. So 3, then plus 4, 1, 4. So like that it will be, the stability will be there. So same as the next one is also, that means 1 is more stability than the 5, then 4 only. Then this 8 is more than 5, 5 is more than 4. So 1 is like this. This is the stability order only. So same as here is also, here how many 3 carbon 3 alpha is there, and then here also 3 alpha is there. That means in between that double bond will be there. So now we just say 3, 3, 6, then 1 alpha hydrogen. That means in this one it have what alpha hydrogen is there, that one we have to add 1, and then it will calculate, and then we will get the total is 7. The same as the next one is also. Then the next one is also the same. Now another one example is also same. Here 3, then here now here this, in this one 3, 3. So 3 carbon. So now here also 3, 3. So now we just see 3 hydrogen. Here also 3 alpha hydrogen, 6. Then here 6. Then here 3. Then 6 plus 6, that is 12. Then 1 alpha hydrogen, that will come as a 13. So these are the applications of the hyperconjugation. So hyperconjugation is the stability of carbocation. Then the next one is stability of free radicals. Then the stability of alkenes. Then electrons donating effect of alkyl group. So this is the applications of the hyperconjugation. The last one is the electromeric effect. So electromeric effect, it will represent it as a E effect. When a multiple bond or double bond or triple bond is exposed to attacking the reagent, E electron, that means electron pairs of bond or bonding electrons are transferred completely from one atom to the another. Example we just see. So that means here is the double bond only. So this double bond we have to transfer to the next one. So when it is transferred to the next one in presence of what? Attacking reagent, then that will carry what? Positive charge. Before it is sufficient, but when it is given to the next one, then it will have what? Positive charge. So next one it will carry for what? Negative charge, because this carbon will have what? More. So this is the examples of the electromeric effect. So same as the triple bond is also see here given to here. This one will have what? Negative, positive charge, and then the next one will have negative charge. So now some important points of the electromeric effect. So this is a temporary effect. So whatever the electron transfer and this thing, this one is the temporary effect. This one is temporary effect. Only occurs in multiple bonds, not in single bond, double bond or multiple triple bond. Now displacements of pi, then electrons only. So that means here pi bonds will be there, that will be displaced. Then only occurs in the presence of attacking agent. So if it is not attacking agent is there, that will not be done the transferring of electron. Now the next is, we just see another example here, ethene. Then in presence of attacking reagent, then positive charge, negative charge. Here also the same as in presence of this, then negative charge will be there, then this positive charge. Then here ketone given to here in presence of attacking charge, then positive charge, then negative charge. So in nitrile also same as like this only. Now types of electromeric effect is plus effect and then minus effect. So minus plus effect, let's see, if electron pairs shifted towards the side where the attacking reagents to be attached. Now example we just say CH3, then CH double bond CH2. So this E is the attacking reagent. So this attacking, when this one will attach to here, that means this carbon will attach to this E only. E now here. And then it will, this one given to here, that means what? It will have more electron. The more electrons will attach to this E. And then this one will carry what? Positive charge, because it is less electron. So like that the next one is also here ketone. So these ketones that will attach to hydrogen, this is the attacking reagent only. This hydrogen is less electron, and then this one break and then given to here. So when it is given to here, that means what? These oxygens will have what? More electron. So when it is more electron having, then that the last one will be attached to here, and then it will get this OH here. Now let's see another one, minus E effect. If electron pair shifted away from the side where the attacking reagents to be attached. Now here we just see another example, CH3, CH double bond, CH2, then E is the attacking reagent. So given breaking and givens to here, negative charge, and then this negative charge here, this will attach to this one, that means this one will attach to this, that means opposite to the plus E effect, and then here cyanide attached to this, and then we will get this, because this attacking reagent will have what, more electron. Now some uses of electromagnetic effects is there. Attacking reagent, so at A positive, that means positive charge, and then R negative charge. Now here methyl cyanide and then water, so this one positive charge will attach to here NH, and then givens to here. So when double bond, triple bond break and givens to here, that means more only nitrogen, the more one will attach to here. After that here hydrogen will come, and then this one will less, it will attach to here, and then the compound is this. So this one is minor plus effect. And then the next is CH3 and then CH3 and CH double bond is there, then givens to here same as this one, but this one is different, ketone, then hydrogen cyanide, then react with this, the attacking reagent is hydrogen cyanide, so this is similar to the minus E effect. And then the previous one, it is similar, the first one is similar to the examples of plus E effect. So this is the class for today. Thank you.